Okay, so this video is going to cover ionic bonding. Remember that ionic bonding, just like ionic nomenclature, is governed by charges, by positive and negative charges. And when we did ionic nomenclature, we spent a lot of time doing the drop and swap. Ionic bonding is the attraction between the oppositely charged ions. And remember that ions form when atoms gain electrons and they become negative ions because electrons are negative, or lose electrons and become positive ions because we now have more protons than electrons. In general, we see ionic bonding between metals and nonmetals, but also we can have ionic bondings with acids because remember, acids are governed by the fact they have an acidic hydrogen, a positive one hydrogen. And so because we're dealing with a charge, even though with acids we're dealing with mostly nonmetals, they follow ionic convention because of the positive and negative nature of that bond. A difference between ionic compounds versus covalent compounds, covalent compounds form shapes, right? Trigonal planar, tetrahedral, pyramidal. Ionic compounds don't form shapes that way. They form like crystals, think like salt. So we are going to show in what we're drawing how the ions are formed, not necessarily how the crystalline structure is formed. That would just take forever, and it's not a great use of our time. We can show everything we need to show by the transfer of electrons, which would then be, this is how we made the ions, and then we understand how positive and negatives attract, and then they form those repeated crystal structures. So we're only going to go through 3 examples because this is way more straightforward, in my opinion, than what we've seen in the previous video, which is for covalent structures. So, barium chloride. We're going to lean heavily on our knowledge of nomenclature here. So, barium chloride. If this was the nomenclature unit, what would I tell you to do to come up with the formula for this? Yeah, write things on the top, remember? So, barium, Ba plus 2, chlorine, Cl minus 1. I know, drop and swap, this is going to be BaCl2. Okay, we already know this. This is old news. What we're going to do is talk about how is it that this becomes Ba plus 2? Why, how does this become Cl minus 1? And then why are they attracted to each other? They're kind of like, in biology, think of like a symbiotic, mutualistic relationship. They're helping each other out and they're both benefiting. The goal of atoms gaining and losing electrons to become ions is to acquire the configuration of a noble gas. We know that barium, because it's in the 2A column, wants to lose 2 electrons, because if it loses 2 electrons, it'll go from having 56 electrons to 54, and that's the same amount of xenon, and then it'll have a full outer shell. We know that chlorine wants to gain an electron, so it'll be like argon. So how do these two work and help each other? Well, barium's like, sweet, here, you, chlorine, you take an electron, and your other friend, chlorine, you take an electron, and now everyone's happy, and oh, now I'm a positive ion, and you're a negative ion, and we stick together. That's essentially what's happening. So how do I draw that? Easy. Barium. It's in the 2A column. I know it gets 2 dots. 1 dot, 2 dots. Okay? Chlorine. I've got Cl2 in my formula, so I'm going to draw 2 of those bad boys. And each of them gets 7 dots, right? So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So how do I show barium giving up 2 electrons to become barium plus 2 and chlorine receiving 2 electrons becoming Cl minus 1? It's so hard. Ready? I'm going to draw an arrow from barium to chlorine, showing that the electron is moving from barium to chlorine. That's why it has to be an arrow, not a line. Arrows show direction, lines don't. So my arrow has to have a point. The point has to be pointing to chlorine. So it's showing that the electron is going from barium to chlorine, and then from barium to chlorine. And that, ladies and gentlemen, is it. All right? I moved the electrons. Barium is now +2, chlorine is now -1. They stick together like oppositely charged refrigerator magnets. Easy peasy. All right, let's do another example. So we have aluminum sulfide. So Al +3, S -2, drop and swap, Al2S3. So what does that mean for me? I need to draw how many aluminums? 2. How many sulfurs? 3. Where do my electrons need to go? From the aluminum to the sulfur, just like they went from the barium to the chlorine, right? They need to go from the thing that's becoming positive because it's losing electrons to the thing that's becoming negative because it's gaining electrons. So I'm going to draw 2 aluminums, Al, Al. Each aluminum gets 3 electrons. 1, 2, 3. 1, 2, 3. Then I'm going to draw 3 sulfurs. 1, 2, 3. Sulfur's in the 6A column. So each sulfur is going to get how many dots? 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And then I'm just going to start moving electrons until I run out. So this electron can go here, and this electron can go there. Now, I have one more electron and no more spots. That's okay. That's why I have 3 sulfurs. So here, this one goes here, and this one goes here, and this one goes here, and this one goes here. Is there a particular way I have to draw this? No. But I try to make it not look like spaghetti noodles, right? Try to make them not cross. Don't make someone go crazy trying to look at your paper. So I try to draw them so there's not so much overlap. If there's a line here or there that crosses, not a big deal. But each aluminum loses 3 electrons, becomes +3. Each sulfur gains 2 electrons, becomes -2. All right, our last example, hydrochloric acid. So remember, hydrochloric acid is made of nonmetals, but they behave ionically because of the acidic hydrogen that all acids have to have. So I know that hydrochloric acid is made up of H+1 and Cl-1. And so that's how I draw it, right? So I'm going to have my H, and it has 1 dot because it has 1 valence electron. My Cl is going to have 7 dots because it has 7 valence electrons. And my electron's going to move from the hydrogen to the chlorine to become H+1. So chlorine becomes Cl-1. Easy enough?